Hi ladies, this is Mrs. Blaufuss here. Today we're going to look at the centroid, and the centroid is a special point of concurrency, and we're going to talk a little bit about its characteristics. So first of all, you have a couple new vocab terms. The first one is center of gravity, and the second one is the centroid. So if you remember from our previous lessons, we've been working with points of concurrency, the three angle bisectors, that's the incenter, and the special thing about the incenter is that it is the center of the circle inscribed within our triangle. And this means that it's equidistant from our sides. Of our triangle. The second one, the circumcenter, the special thing about the circumcenter is it's the three perpendicular bisectors, the point of concurrency with the three perpendicular bisectors, and this one is equidistant from the vertices of our triangle. And the third one is the orthocenter. And the orthocenter is the point of concurrency of the three altitudes of our triangle. Now today we're going to look at a new point of concurrency, and this is the point of concurrency for the three medians of our triangle. Now if you remember what a median is it's a segment that goes from a vertex of a triangle to the midpoint of the opposite side. So this is something that we worked with earlier this chapter. And in this diagram, you know that this point here is the midpoint because it divides the side into two congruent segments. Okay, so you know that these are the midpoints. That little scribble is compliments of 2-year-old Maggie Blaufuss. Thank you, Maggie. All right, so we know that these are midpoints because the segment is divided into congruent pieces. Okay, so the point of concurrency with the three medians, we call this the centroid. So the three medians of a triangle are concurrent. The point of concurrency is called the centroid. So some special characteristics with the centroid is that the centroid of a triangle divides each median into two parts. So the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint of the opposite side. And remember, if you're having a hard time determining what is the midpoint or what is the opposite side, put your finger on the vertex and the side that you are not touching is your opposite side. So the centroid of a triangle divides each median into two parts, so the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint of the opposite side. Here's a diagram that you have on your note sheets that may help that. And so this is a theorem, it's been proven. The medians of a triangle intersect at a point, P, that is 2/3, this is just another way of saying our conjecture, that is 2/3 the distance from each vertex to the midpoint of the opposite side. So if P is the centroid in this triangle, ABC, then the distance from A to P is 2/3 the distance of the whole thing. And the distance from P to D is 1/3 of the entire median. Okay, so the distance from the vertex A to the centroid P, so AP is 2 times the distance from the centroid to the median. Oops, this is P. So AP is 2 times PD. Another way to think of it is that since the median is divided into 2 pieces, one twice as large as the other, the distance from the vertex to the centroid is 2/3 the distance of the entire thing. Okay, so we'll look at a couple practice problems in just a minute, and we'll refer back to that diagram, but I want to define this last piece, the center of gravity conjecture. So the center of gravity is like the balancing point. And the centroid is the center of gravity of a triangle or of a triangular region. All right, so let's look at this triangle, and we're going to look at how to construct the centroid. So first step is we want to find our medians. And how are we going to find our medians? If you remember from previous constructions that we did, we're going to bisect the segments. And in this case, the segments are the sides of our triangle. So you can use your compass Why is this? All right, we are going to bisect the segments or the sides of the triangle. So in order to do that, we're going to take our compass and we are going to put the center of our compass on a vertex of the triangle. And our perpendicular bisector conjecture says if a point is equidistant from the endpoints of the triangle, or the endpoints of a segment, it is on our perpendicular bisector. So we're going to find 2 points because we need 2 points on every segment. I'm having a little bit of difficulty with the actual construction tools on here, so I'm going to just list the steps for you in finding the centroid of a triangle, and I'm going to have to handwrite this. So imagine this is your triangle. You're looking for the midpoints because the centroid connects the vertex to the midpoint of the opposite side. So in order to find the midpoints, we'll construct midpoints by finding the perpendicular bisector of each side. So it's not the perpendicular bisector you're looking for, The only reason you're finding the perpendicular bisector is that the midpoint lies on that perpendicular bisector. Once you have the midpoint of all three sides, then you can connect the vertex to that midpoint. And that centroid is going to be the center of gravity of that region or of your specific triangle. So let's look at some specific examples of the relationship between the medians and the centroid. So this is something that is not on your note sheet, but please refer to this diagram up on the board. Point G is the centroid. Find the missing measures. So if G is the centroid, the first thing I'm going to do is mark what I know about my diagram, because that's always going to be my first step, is marking information that I already know. So G is the centroid. So that means that G is the point of concurrency for all the medians. So that means BD is a median, which makes these two pieces of the side AC congruent. These two pieces are also congruent, and BF and FC are also congruent. So that's the very first thing I'll do when I mark my diagram, or when I realize that G is the centroid, and that's a given. So now it tells us that AG is equal to 8, and we want to find FG. Well, let's refer back to our notes about the relationship between the two segments that the median is divided into. And it says that from the vertex to the centroid is twice the distance than the centroid to the median. Okay, so AG equals twice FG. If AG equals 8, then FG equals 4, because I'm going to divide both sides by 2, because AG is twice as much as FG, twice as long. So let's look at the second one. EG is 3 units, and that's the distance from my centroid to the median. And now I need to find the distance from E to C. I need to find this whole median. So we know that the distance from the centroid to the median is half the distance then from the vertex to the centroid. So that makes this GC segment 6 units. So if we're looking for the entire thing, EC is 6 plus 3, or 9. And then our last piece, BD, this whole segment is 9. We need to find BG. BG is the distance from the vertex to the centroid, and that is 2/3 the distance from the vertex to the median, which is 9. So BG equals 18/3, which equals 6 units. So now I'd like you to try some problems on your own, and you can find those on the 3.9 homework worksheet. You can work in small groups of 3 or pairs of 2, or if you'd like, you can work independently. So please, if you have any questions, please come see me when I return, either during dasher time or before school. And if you'd like to send me an email to set up a time to meet, please do that. Thank you, ladies, and we'll see you next class.